Greetings, I'm Dev the developer.
And I'm Glitch.
We just finished covering null, what it is, why it crashes programs, and the toolkit for handling it. Today we're looking at a problem that comes up the moment you start comparing objects. We're going to watch something that looks correct produce a result that feels wrong. Let's start with something simple. Glitch, create a point class. Give it an X and Y property.
A class for a single point in space. X and Y, I'll make them properties so they're accessible.
Good. Now create 2 point objects with the same coordinates and compare them with double equal.
I'll just drop them right at the top of the file. Wait, false, they're the same. X is 3, Y is 7, both of them. That should be true. Is the CPU malfunctioning? Should I run a self-diagnostic?
A class is a reference type. When you write new point, C# allocates an object in memory and gives you a reference. Think of it like a label. A is a label pointing to one box. B is a label pointing to a completely different box.
And the double equal operator on classes doesn't ask, do these boxes have the same contents? It asks, are these labels pointing to the exact same box in memory?
Exactly. That reference equality, it's the default for classes. If you have 2 bank accounts with the same balance, they're still 2 different accounts. Identity is meaningful there.
But for a point, identity isn't meaningful. The data is the identity. 2 instances with the same values should be equal. So how do we fix it? Manual boilerplate.
We used to, but now we have the record keyword. Glitch, change the class to record.
I'll navigate down and swap the keyword. One word change, class to record, and now it's true. The whole boilerplate problem just vaporized. I wish I could refactor humans that efficiently.
The compiler generated the equals method, the get hash code method, and the operators. All of that from one change. Now, there's a more concise way to write this. Positional syntax.
1 line and a semicolon, that's surprisingly concise, even for a machine. And wait, what did it print? It generated a ToString override 2, type name and property values, free and readable. I like the efficiency. But can I change the values after construction?
Try it. Set p.x to 99.
I'll try to overwrite the value. Error, init-only property, so records are immutable by default. They're frozen at the moment of creation. Persistent state, immutable data. I respect that level of certainty.
If you need a modified version, you create a new instance, and the with expression makes that easy. Show them.
I'll use the with keyword to create a sibling instance. P1 is still at 1, P2 is at 99, the original is untouched. The with expression created a brand new object with all the same values except for the ones I specified.
Let's see a realistic example. Write a bug report record with an ID, title, status, and assignee.
I'll set up a bug report record, transition it from open to closed. Nothing is overwritten. Every state transition produces a new instance. The original is always preserved. It's a snapshot of state at a moment in time. Every version of a record that ever existed could be retained. No data ever disappears. A complete, tamper-proof record of every modification from the initial state to the final objective, which is extremely useful for debugging.
Right. One more thing. Records are still reference types. They live on the heap, just like classes. The difference is the equality behavior, not the memory model.
So there's still boxes on the heap, but double equal now asks, do these boxes have the same data? Instead of, are these labels pointing to the same box?
Exactly. A keyword is a declaration of intent. Class for identity, record for data.
Once you see the pattern, everything else follows from it.
Go write a record, give it a nullable field, use a with expression to create a modified copy, and confirm the original is unchanged. The immutability is the key. Don't just watch it, do it.